Now for the fourth question, we are given to solve this equation of in terms of z basically, and we have to give our answers in the format of x plus iy. So wherever there is z, it's nothing but x plus iy. So now the equation is in this format, and z star is nothing but the complex conjugate of z. So if z is equals to x plus iy, then z star automatically becomes x minus iy. That's what we call as the complex conjugate of z. Now, as we can see that there is a multiplication of z star. Okay? So that z star is nothing but x plus iy multiplied by x minus iy. So it's in the format of a plus b, a minus b, which is nothing but a square minus b square. So a square minus b square. Over here, this will be x square minus, we know that I square is nothing but -1, and this is y square. So finally, this is x square plus y square. So whenever there are two complex numbers which are multiplied and one is the conjugate of the other complex number, the answer will always be the x square plus y square, always. So that's the kind of thing that we'll be needing over here to go ahead and solve this. So if I replace everything in the format of x plus iy, so this is going to become 5 times x plus iy, which is nothing but 5x plus 5yi. Now that is divided by 1 plus 2i. Now I can take a complex conjugate of this as well. I can just multiply this, like like the what do you call that process? That process is called as rationalization, right? So yeah, rationalization is what something I'm doing over here. So 1 minus 2i I'm multiplying over here, and also on the top. Basically, we do this process to get rid of the complex numbers from the bottom and convert it into a real number, because I know that the multiplication of a complex conjugate with the original complex number is always a real number. There is no item over here. So that's the trick that we always use for this kind of questions, and that's the reason it came to my mind. Now the other thing is nothing but over here minus sign with x square plus y square, because x square plus y square is the output of this multiplication. Then there is plus 30 plus 10i is equal to 0 plus 0i actually. That is in itself 0. But yeah, we can represent this in this format. You will get an idea why am I doing that. Now over here, if you go ahead and solve this, so 5x into 1 is 5x. Then 5x into minus 2i is minus 10xi. Then 5yi into 1 is plus 5yi. And this becomes minus 10yi minus 10yi square actually, because I and I are there. And in the bottom, I told you this is always the first term square plus the second term square. So I mean x square plus y square. So 2 square is 4, 1 square is 1, 1 plus 4 is 5. So in the bottom it's 5. Over here it's minus x square minus y square plus 30 plus 10i is equals to 0 plus 0i. Now I can just simplify this whole equation and multiply both the sides by 5 to get rid of this denominator. So in the first term, if I multiply my 5, this 5 and that 5 will get cancelled out. And this will become 5x minus 10xi plus 5yi. I square is basically -1. -1 into -1 becomes positive. This is 10y. And now this becomes minus 5x square minus 5y square. Remember, I'm multiplying 5 on both the sides, right? Plus 150. 30 times 5 is 5 3s are 15 into 10 is 150 plus 50i is equals to 0 plus 0i into 5 is nothing but 0 plus 0i. Now what I can do is I can combine the real terms together, equate it to 0, and I can combine the imaginary terms and equate it to 0. From there, I'll be getting two equations. And if we are having two equations with two unknowns, we can obviously go ahead and solve it with some method. So let's try to do that. So first of all, let me club in the real parts. So the real part includes 5x, then plus 10y. Then we are having minus 5x squared minus 5y squared plus 150. Now that is my real term. And for the complex terms, I am having 5y minus 10x Then plus 50. This is your items. Okay, it's plus 50. I, it's equal to 0 plus 0 I. Now I can just say that, yeah, this is equal to 0 and this is also equal to 0. So this implies 5x plus 10y minus 5x square minus 5y square plus 150 is coming out to be 0. And this also implies that if I make, let's say, y the subject of formula, if it's equal to 0, then this will become 5y is equals to 10x minus 50. If you solve this ahead, if you divide both sides by 5, we know that, see, first of all, how did we get this equation? Because this is equal to 0. So I shifted the other things on the right side so that I get this. Now, basically, to make y the subjects, I need to divide 5 on both the sides. So this becomes 2x minus 10. So my y is equals to 2x minus 10. Now what I can do is I can take this y, substitute it in place of y's over here. So this equation is now in terms of x. Then I'll be getting multiple values of x, basically two values of x. And then by using those two values of x and substitute it over here, I can get two respective values of y. And this will be the answers of z for this particular question. So let's go ahead and do that. I'll be substituting this y. I'll be substituting this y wherever I see y's over here. So what do we have? 5x plus 10 into 2x is what? 20x. So that's 20x. Then 10 into minus 10 is basically minus 100. Then minus 5x squared, minus 5x squared. Then minus 5. Then we are having the square of this. 2x squared becomes 4x squared. Then 2 times 2 minus 10, so that becomes minus 40x plus minus 10 squared is 100. So we are done with that. Plus 150 is equal to 0. Now let's simplify this. Let's grab all the x squared terms, or else I'll just open the bracket for simplicity. So 20 plus 5 is 25x. Then this minus 100 plus 150 becomes plus 50. I'll just eliminate the terms that we have done. So that is plus 50. Then we are having a 5x minus 5x squared term. Then this is minus 20x squared term. Minus minus is plus. Then 4 5s are 20 into 10 becomes 200x. This is minus 500 is equal to 0. Now I am going to transfer everything on the right hand side. So this is minus 25. On the right, it becomes positive 25x squared. Then the x terms is 200 plus 25 is 225. But on the other side, it becomes minus 225. Right? X. And lastly, we are having 50 minus 500, that is negative 450. On the right, it becomes positive 450. And that is equal to 0. Now you can maybe take the common factor out, but I'll be simply using my calc to get the roots of this equation. So 25 is the value of A, minus 225 is B, 450 is C. So the values of x I'm getting are 3 and 6. X is equals to 3 or x is equal to 6. This also implies that the factors are going to be x minus 3, x minus 6 is equal to 0. So these are the values of x. Now to get the respective value of phi, what I can do, I can use this equation, place in x. So this implies my y when x is equal to 3 is 2 times 3 is 6, 6 minus 10 is minus 4, or my y is equal to 2 times 6 is 12, 12 minus 10 is 2. So these are the two values of x and y's and respective values of x and y's. So what is the values of z finally that you get from this equation? So z1, you can say that is equal to 3 minus 4i, and z2 is equal to 6 plus 2i. So this becomes the final answers of question 4. I know that this method is pretty pretty lengthy, but yeah, The basic idea is to convert the z's into x plus iy, whatever is given to you over here. Convert the complex conjugate into that same format. Then, if you are having fractions, you do the conjugate method, or else I just keep on forgetting the name of that method. I guess what's it called? Starting with R, right? Some method that I told, right? That where we multiply the conjugate over here on top and bottom of this part so that this gets eliminated. That stuff is important. If you know this stuff, everything is equal to 0 plus 0 I. Then you can take the real term equal to 0, imaginary terms equal to 0. From there, you'll be getting two equations, as you can see over here. Then you can take one equation, substitute it in some other equation, or whatever is the kind of two equations. You can also use simultaneous equations or different ways to solve them. So yes, with that being said, that's the answer of question 4, and we are done with this question.